All right, in this lesson, we're going to talk about the relationship between the lengths of the sides of a triangle and the measures of the angles of a triangle. And it turns out with triangles, what always happens is your longest side is always opposite the largest angle. And what I mean by opposite is that the largest side, the longest side and the largest angle don't touch each other. They are on across the triangle from each other. So for example, in this triangle here, ABC, the longest side is that 34. The opposite angle, the angle across from it, is angle B. And you know B is the opposite because B is the only angle on this triangle that doesn't touch side AC. It doesn't touch the 34. So since AC, 34, is the longest side, angle B, which is across from it or opposite from it, has to be the biggest angle. The same thing happens with the small side and the small angle. So our shortest side on this triangle is AB, which is 15. That means the smallest angle is going to be opposite it. It's going to be across the triangle. So angle C over here is going to be our smallest angle. So largest angle is always across from the longest side. Smallest angle always across from the shortest side. Now, the other day we had a problem that involved an isosceles triangle. And in some of the classes, we talked about if a triangle has two congruent sides, it always ends up having two congruent angles. And that plays into what we're talking about here, this relationship between the sides of the angles. So if you look at this isosceles triangle, DEF, it doesn't really have a longest side. It has two longest sides that are exactly the same. And what happens because of that is it doesn't really have a biggest angle. It has two biggest angles that are also exactly the same. So you do have those special situations with isosceles and equilateral triangles where you'll have two or three sides that are exactly the same. What'll happen is the opposite angles also end up being exactly the same. But we're mostly going to focus on scalene triangles here, triangles where all three sides are different and all three angles are different. So we're going to do a few examples. And what it asks us to do here is order the angles of the triangle from smallest to largest. But it doesn't tell us information about the angles, it just tells us about the sides. So we have to use that rule. We know that the largest angle is across from the longest side and the smallest angles across from the shortest side. Now, like on number 2, you have a diagram. You can kind of look at it and get an idea of which angle is largest and which is smallest. But sometimes it can be really hard to tell. For example, it's really hard for me just to be able to look at this and know right away if angle M or angle K is larger. But when I use the side measurements, I can know for sure. So what you want to do here, if we're going from smallest to largest, you want to start with the shortest side. So on number 2, that would be the 13. So the smallest angle will be across from that. It will be opposite the 13. So you go across the triangle to the opposite end, and you find the angle that's not touching the side with the 13, and that's angle L. So L is the smallest. So I'm going to write that first. And it's the smallest because it's opposite the shortest side, which is side KM. All right, now I want to go to the next shortest side, the medium side, and that is side LK, which is 18. So now I go opposite the 18, and I get to I get to angle M. So angle M is going to be my middle angle. It's bigger than angle L, but it's not the biggest angle in the triangle. And then to find my biggest angle, I take my longest side, which is LM. It's the 20 centimeters. And I go across, I go opposite from that, and I end up at angle K. So angle K is my largest angle. So that's all it asks us to do. And just to be clear, I'm going to, just so it's really clear what we're talking about, I'm going to make a little note that angle L is our smallest, and angle K is our largest. So we don't know the exact measure of the angles. There are ways to find that using trigonometry. It gets a bit more complex. But we do have an idea. We know for sure which angle is the smallest and which angle is the largest. And we can actually, there's ways we can use this too to come up with ranges of angles. So we can we can get a pretty good approximation of what it's going to be. But right now, we're just going to focus on smallest to largest. So at number 4, we don't have a picture. And if you wanted to, you could draw a picture of a triangle TUV, but you don't have to. Here's what you can do. You can find the opposite angles by looking at the letters of the points they use. So here's what I mean by this. The first thing they give you is side UV. Well, we know side UV has to be opposite angle T, because T is the only letter that's not used here. So if you were to draw this triangle out, you would have a side UV, and then on the other end of the triangle, you would have point T. Point T would be the one point that doesn't touch this side. So that's where the opposite angle is going to be. So you always just look at which letter isn't there. So for side TV, the letter that's missing is U. So we know that has to be across or opposite from angle U. And then our last one, TU, it doesn't give us a V. So we know that one, the third one, has to be across from angle V. And so now we can order these smallest to largest by looking at the measurements of the opposite sides. So our shortest side is TU. It's 9 yards long. The angle that's opposite from TU, we said, was angle V. So angle V is our smallest. The middle side in terms of length is TV. It's 14 yards. The opposite angle from that is angle U. So that's going to be the middle angle. Our largest angle is going to be opposite UV, which is the largest side. And that's going to be angle T. So angle T is the largest. So we, without even having a diagram to look at, without being able to see what those angles look like, we can still order them from smallest to largest just using the information we have about the side measurements. And that's a big thing with geometry, taking little bits of information you know and using that to draw conclusions about other things that we know as a result. So let's do another set of examples. This time we're going the other direction. We're starting with the angles and we're finding the sides, or we're finding which side is shortest, which side is longest, which side is in the middle. So again, we're going from little to big. So we need to find the shortest side first. So we do the same thing. On number 10, we're going to start with the smallest angle, which is angle N. It's 36. If I go across or opposite from the 36-degree angle, I hit this side over here. This is the one side of the triangle that does not touch angle N. So my shortest side is going to be side LM. That's the opposite side. So I'll make a little note that this is shortest. To do the middle side, I find the middle angle. So my next angle is going to be 46. And if I go opposite the 46-degree angle, I want to go to the side of the triangle that does not touch angle M. And that's going to be side NL or LN. And order doesn't really matter here. I'm going to go NL. Feel free to write it either way. That's going to be my middle side because it's across from the middle angle. My longest side, and on this triangle, you can kind of tell it stands out that this side will have to be longest, is MN. Because that is across, that's opposite from that 98-degree angle. So that has to be the largest side. So MN is my largest side. And then finally, we have problem number 12, where we're doing the same thing without a picture. And this time, again, it gives us the angle. We've got to figure out the sides. And we can do the same thing we did on the one on the previous slide where we didn't have a diagram. We can use the letters to our advantage and figure out what the opposite sides are. So I'm going to, again, kind of make a note off to the side of what my opposite sides are. And I have angle S is 50 degrees. Right now, I just want to know what side is opposite from angle S. Well, again, I'm going to use the letters that aren't there. So angle S, I don't have the T or the U. So the opposite side has to be side TU. Angle T, I do not have the S or the U. So my opposite side would have to be US or SU. Again, the order doesn't matter as long as you have the right two letters. And then my third angle they give me here is angle U, and that does not have the S or the T. So that's going to be opposite from side ST. So basically, the opposite sides are the sides with the two letters that you don't already have. So side TU is not going to touch angle S. It's going to be opposite from it. Side US would not touch angle T. It would be opposite from it. And now you can use the angle measurements to order these from shortest to largest or longest. And so our smallest angle is angle S. It's only 50 degrees. So that means our shortest side is side TU because it is opposite from that. And I'll make a little note that this is the shortest. The middle angle is angle U. It's 60 degrees, and it is opposite from side ST. So ST will be our middle angle. And then our largest angle, our longest side, is going to be across from the largest angle. So it's across or opposite from angle T, which was 70 degrees. So side US has to be our longest side. So that's how you can take information about the sides or the angles of a triangle and use that to find out information about the other one. So if you know about the sides, you can figure some things out about the angles. If you know the angles, you can figure some things out about the sides. So there you go.